Hi, today I want to introduce dynamic memory allocation in C. So the purpose of this video is going to go over the basic concepts behind it, and the next video is going to go over how to actually implement it in C with all of the different function calls like malloc, calloc, realloc, and free. So when a process is created, of course, the process in memory, it has this general layout. So different diagrams will show it differently, but basically in memory, the memory for a process has the code for the process. It has that section dedicated to the code. This is usually at the beginning, at the lowest level of the memory. Then it has read-only data and global data. Then you have this interesting section at the bottom with the stack, or at the top, I guess, with the stack and the heap. So the stack is for local memory and static memory allocation, and the heap is for dynamic memory. So let's talk about static first. So static memory allocation is basically just how you declare values normally. How do you declare memory normal? How do you declare variables and arrays and all of them normally? That's usually static. And there's some disadvantages to static because maybe you want to have a program, let's say, that the user types in a bunch of numbers and then the program calculates the mean, median, mode, and then standard deviation and all of that stuff of that data set, but you don't know how many numbers the user is going to type in. It could be 10 numbers, it could be 1,000 numbers. So one way about going about this is you could declare a gigantic integer array or double array or float array. You could declare a gigantic array so that way the user can just keep typing a bunch of numbers, and they're probably not going to type a million numbers, you know? That's one way to go about it, but that has severe disadvantages to it as well because we can waste memory that way. With dynamic memory, however, we can declare exactly how much memory we need even during runtime, and we can resize the memory. So let's say we need more. Let's say we have an array and we need to add more values to it. We can resize it, or we can actually shrink it too if we want to delete things. So those are some benefits to dynamic memory. So first, let's talk about what the heap looks like. The heap, you can think about it like a pool or a bucket of memory. It's a pool or bucket of memory that you can reserve for different purposes. So maybe this section right over here was reserved for something like, I don't know, it could have been reserved for a giant integer array, and maybe this section over here was reserved for some large structure, and this section down here was reserved for a string, let's say. Okay, now let's go over what a general call looks like. So it'll look something like this. So we have our integer pointer. Let's go in green. We have our int pointer. This is going to be our array, and then we call malloc. Malloc is the most basic call for dynamic memory allocation. It stands for memory allocation, malloc. So here in the brackets, ooh, that was bad. In the brackets over here, we have 10 multiplied by the size of the integer. Size of int, this basically just returns the size of an integer data type, which is going to be most likely 4 bytes. So this is 4, so it's going to do 10 times that, so 10 integers. So basically, this array, we're allocating enough memory for 10 indices. So with malloc, what it does now is it'll go and look in the heap, look for somewhere we can allocate some memory, and it'll look, okay, over here. Then it'll reserve the memory like this. Let's say it reserves this much. All right. Then it will return the pointer to that beginning memory address of where the memory was allocated. So, and what this part of over here means, this int over here, what that means is this is a typecast because technically malloc returns what's called a void pointer. Void pointer looks like this, and what a void pointer is essentially that means that it points to anything. It can point to an integer array or a string, float, or double array, or it can point to anything. Because Malik doesn't care what it is that you're allocating memory for. So it's very general. And by this is just common practice that we typecasted. This is called typecast. We typecast it to say, okay, it's not returning a void pointer necessarily. It's returning an integer pointer, like that. Okay, now what about the event where Malik fails? Because Malik can fail, and it will generally fail if, let's say, we don't have enough memory. So let's say some other process declared this much memory, and then some other process declared this much memory. Let me clean this up. There we go. Let's say declare this much, and then for Malik, let's say we do this Malik column, and we need another section of memory. Maybe we need a section that's approximately, let's say, this big. So it's too big. We don't have enough memory in the heap. When this happens, Malik will return null, which is essentially nothing, empty, saying, hey, Malik failed because, hey, we don't have enough memory. So you can use this to check if you have enough memory for whatever your purpose is. Alrighty, and that concludes a basic introduction to dynamic memory allocation. In the next video, we'll go over how we can actually program this in C. See you guys there.